Hello guys, welcome to my channel. This class I will continue the MOT theory part 2. If you don't know the part 1 or if you want to see the before class, then check my channel. There is a before class which is part 1 of MOT theory. So I will continue this class. Before this class, please watch the before class to understand the today's class. So I am explaining the how to draw the MOT theory diagrams. MOT diagrams. We take like this to one atomic orbital of one atom and atomic orbital of another atom. By combining this, we got molecular orbital. And this we got it is atomic orbital, and this also atomic orbital of one atom. This is bonding molecular orbital which is we already understand it before class. This is anti-bonding molecular orbital. As we know, bonding orbital is more stable. Bonding orbital is more stable. And anti-bonding molecular orbital is less stable. Molecular orbital is less stable. And from bonding molecular orbital, then for the anti-bonding molecular orbital, the energy is more for anti-bonding molecular orbital. So from bottom to top, energy increases like this. Energy increases. Energy increases from bottom to top, as anti-bonding molecular orbital has more energy but less stable, but bonding molecular orbital is more stable but less energy. I am writing here energy order. This bonding molecular orbital is less than anti-bonding molecular orbital. Should know this order. So how to combine the two atomic orbitals? First I am taking 1s plus 1s. Here we already said, means before class said, we will pronounce with sigma and pi and sigma and pi, and bonding means sigma and pi, antibonding means sigma star and pi star. 1s plus 1s equals to, I am writing for sigma and sigma star. 1s and 2s plus 2s, sigma 2s, sigma star 2s. And if you take P, there is three components: Px, Py, Pz. As a molecular orbital has three shells, so Px, Py, Pz I am taking. Okay, so 2px plus 2px is to pi star 2px pi 2px, 2py plus 2py pi 2py star pi 2py. But if we write 2pz plus 2pz, we will take it as sigma star 2pz, sigma 2pz. When it is only px and py, we will take the py, we take only the this one pi value, only pi. Okay, but when we take the 2pz, we will take the sigma value, sigma, and when it is 1s and 2s also, we take the sigma. Okay, let's continue. Now how to write the molecular orbital electronic configuration. there are two types of to write the molecular orbital configuration. When we write the molecular orbital configuration, should directly like sigma 1s. I'm writing the order, so energy order, so you can understand the what energy, which orbital has more energy, which shell has more energy. Sigma star 1s, sigma 2s, sigma star 2s. So as I am increasing the 1s 2s and so on like this, I'm going to increase like that. When we write the p value, pi 2px is equal to pi 2py, we write like this, and greater than sigma 2pz, then again pi star 2px is equal to pi star 2py, and is greater than sigma 2pz. So this how we write the electronic configuration of molecular orbital. But there are two types: before 14 electrons and after 14 electrons is there. Before 14 electrons means this is the continuation which I have written before. Here 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equals to pi 2py, and sigma 2px greater than pi star 2px is equals to pi star 2py. Means this is for this is for this is for up to 14 electrons only. For sir, what is for after the 14 electrons means 15, 16, 17, 18 means so on like that. I'll show you. After that sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Now as compared to this one, we will say pi 2px is equal to pi 2py generally, but we should write first 2pz. Sigma 2pz is greater than, is less than pi 2px is equal to pi 2py, then less than, from next onwards is normal, continuing. Pi star 2px is equal to pi star 2py is less than 2pz, sigma star 2pz. Okay, what is the difference between both of them? We should write here pi 2px is equal to pi 2py, then we should write the sigma 2pz. If you see the difference here, I written first this one, after this one, but what I have written here, first I have written this one, and second this means this one, and next other numbers are constants, means same before as before, so no need. So you should know the how to write this configuration, means 1s, 1s2, 2s2, 2p2, 2s2, sigma star 2s2, 2pz2, means when we write the pi 2px and pi 2py, means when you got 2 electrons, means 1 minute, I'll change it the color before I write. Okay, so when we write the 2px and 2py, 2px1 is equals to pi 2py1, Then you got another electron, means third electron, means you should write here, should write here. So like this you have to write the 2px into y, means it's correct. Before 2px by 2py, 1 is correct. Pi 2px is equal to pi 2py, means here I am writing 2, here I am writing 0, means it's wrong. So you should know the value first, you before shell only, after that you should again fill it the second one, then only it's a particular order. Do not fill the until all shells are is filled with pair of electron. Okay, this is the correct order and it is the wrong order. Next, now I will say the how this one will be in the form of bond order, bond energy stability. How it is useful for MOT theory. MOT theory means bond order. Bond order is directly proportional to bond energy or bond enthalpy. You can do what you want, and directly proportional to stability. Directly proportional to 1 by, means inversely proportional to bond length. Simply I will write it in a shortcut method. BO means bond order, directly proportional to bond energy, directly proportional to stability, inversely proportional to bond length. Means if you see here, all of them are directly proportional. Only bond length is inversely proportional. If you see these 4 items in any of the question or any of the order, only bond length is inversely proportional to three of them. So bond order and bond energy, they are directly proportional. If bond order increases, bond energy increases, bond order increases, stability increases. So bond order increases, bond energy also increases. If bond order increases, stability also increases. If bond order increases, bond length decreases. Bond length decreases. So how? What the bond order? There is a small trick for the bond order and bond energy. I will say it. 14, 13, 12, 11, 10, 9, 8, 15, 16, 17, 18, 19, 20. If you see any of these numbers as number of electrons, if for example O2, oxygen 8 plus 8, 16 electrons, so 16. So for this there is an exact values there. It's the short trick for the finding of bond order. Means 14 means 3. First you should know the value of 14. 14 means 3, the middle number. For 3 you should decreasing the number like 2.5, 2, 1.5, 1, 1, 0.5, 0, and here also 2.5, 2, 1. 1.5, 1, 0.5, 0. If we'll take NO, N, nitrogen means 7 electrons, oxygen means 8 electrons, 7 plus 8 is equal to 15 electrons. 15 means bond order is equal to 2.5. You can write it directly. This is bond order and this is electron number. It is just short trick for bond order. Okay, next, if we see up to now you have completed the MOT theory. Let's see how they are using in the examples. So let me know some examples. I will explain some examples and so the class will be completed because MOT theory has completed. Here I am taking examples O2 plus, O2 minus, O2 plus 2, O2 minus 2. If you are seeing, O2 means 16 electrons and O2 plus means loss of electron. One loss of electron gives rise to 15 electrons. 15. O2 minus means gain of electron, means 17 electrons. And O2 plus 2 means 14 electrons, means loss of 2 electrons. From 16, 2 electrons minus means 14 electrons. And O2 minus 2 means 18 electrons, gain of 2 electrons. So I have said to you 14 means 3. From 14, 15 means 2.5, 16 means 2, 17 means 1.5, 18 means 1. So if you know the value of 14 means 3, then you can check 13, 12. 13 means 2.5, 12 means 2. So directly you no need to calculate the bonding and anti-bonding and varying configurations and calculate how many number of bonding electrons, how many number of anti-bonding electrons. It is a simple trick which is useful for in the matchings. In NEET they'll use in the matchings. It's very important. You will take it very short time. You will complete short time and it is very useful for the next question to solve it in more time. Okay. Sometimes in questions there will be big questions in the NEET exam or any another exam or JEE mains or anything. At that time, this time is very valuable for the bigger questions. So you should know these shortcuts. So it is very useful for you in bigger questions. The time is very valuable. So I am taking now He2, H2, H2 plus and H2 minus. Okay, here we calculate it means 4 electrons. Here means 2 electrons, H2 2, H2 2 minus 1 means 1 electron and H2 minus means 3 electrons. So already you said that 16 electrons, 15 electrons, 14 electrons, 13, 11, 12, 10, 9, 8, up to 8 only. And 14, 15, 16, 17, 18, 19 only I said the small trick. But how to write this bond order? You should wear normal only. But for this, you can wear very short configuration. The no need of bigger configuration, sigma 14 electrons, sigma 1s2, sigma star 1s2. I written. So bond order is equal to 0. Bond order is equal to 2 minus 2 by 2 equals to 0. So next, He plus 2 electrons. 2 electrons means sigma 1s2. Sigma 1s2. So here we got bond before helium. He2 means there is only 1s2 and sigma star 1s2. So 2 minus 2 0, 0 by 2 0. So the bond order 0 means there is that molecule does not exist. The molecule does not exist. There is no exemption for that. He2 2 electrons. We no need to write. We can calculate with this. 2 electrons means 1s2, 4 electrons 1s2, 2s2. Like general configuration. And bond order taking is 2 minus 0 by 2. No antibonding electrons by 2. 2 by 2 is equals to 1. Bond order is 1. He plus 2, which is 1 electron. Sigma 1s1. Sigma 1s1 means bond order is equals to 1 minus 0 by 2. See, 1 by 2 means 0.5. 0.5. Here H2 minus means sigma 1s2, sigma star 1s1 means sorry, not 3. 2 minus 1 by 2. So here also 1 by 2. Same ditto 0.5 we get. So by this way you can get the values of bond order. So here we get the bond order values. Here we got the bond order values 0, 1, 0.5, 0.5. So 0.5, 0.5, 1, 0. By this way you can calculate the bond energy order also. Here 0, 1, 0 means here what is greater one? H2 is greater one. H2 is greater than. And H2 minus is equal to H2 plus H2 He2. Sorry. This is the order for bond order, bond energy, and stability also. Stability also, this is all the bond order. But when compared to stability, we consider the high electronegativity also. Before you are taking one, loss of electron for stability, loss of electron taken as less bond energy and gain of electron because it did have already extra gain. Means for stability He2 greater than He2 plus greater than H2 minus H2 minus greater than H2 for all stability. But bond energy and bond order is same for both of them. No need to worry. But bond length is completely difficult. Completely reverse. Sorry, not difficult. It's completely reverse. H2 will come to front and He2 to back. So because they are the inversely proportional better. So thank you students. Up to here we have completed the MOT theory. For more videos and more classes. For more classes, subscribe to my channel. I have started first time for the classes to know the students how to do with this chemistry. So I have started the new one. So please encourage me and do subscribe and share it and comment also how I explain the classes. Do in comment. Thank you. Like and share, subscribe. Thank you students. Thank you one and all. Thank you. See you in the next class.